Hello, everyone. We are Team 2, and we're presenting the Quain Lawn and Garden case study. So a little bit about the background is that Bill and Jean Quain retired from their real estate business and started off as amateur gardeners on their 25-acre farm. And then eventually their love of gardening continued, and they became a family-owned plant and shrub business in New Jersey and filed for their business license Quain Lawn and Garden in 2018. As they started their business, they quickly realized that they wanted to produce high-quality fertilizer, but that they wanted to keep their costs to a minimum and produce top-notch fertilizer for New Jersey climates. And so the problem statement for our case study is that their business needs to minimize costs for their own fertilizer blend, but also meet a specific chemical composition requirement. Some key insights that we have are to use linear programming to maximize the chemical E-11's proportion due to its lower cost. And the goal is to implement the optimal blend for the Quain Grow fertilizer by balancing the cost and the required chemical composition to maintain a quality product.
Given by Pearson in our case study, we were told the cost per pound for each chemical that we had to work with. Listed in front of you is C30 is 12 cents per pound, C92 is 9 cents per pound, D21 is 11 cents per pound, and E11 is 4 cents per pound. We were then given a list of constraints to work with. Them being that E11 can constitute or must constitute at least 50% of the blend. C92 and C30 together had to constitute 45% of our 50-pound blend. D21 and C92 together could constitute no more than 30% of the blend. And the Quain Grow had to be packaged and sold in 50-pound bags, and that 50 pounds had to be an exact number. With all that information and the cost per chemical, we were able to answer a few discussion questions that were given to us in the case study. Those questions had to be what blend of the 4 chemicals would allow Quains to minimize the cost of that 50-pound bag of fertilizer. And then we had to solve to find the best solution, meaning we had to figure out the lowest cost with those chemicals for a 50-pound bag of fertilizer.
We are looking at the mathematical formulation of cost minimization problem for Quain Grow fertilizer. We aim to determine the optimal mix of chemical components to minimize costs while meeting required constraints. The decision variables represent the quantities in pounds of each component in the fertilizer blend. That's X1 pounds of C30, X2 pounds of C92, X3 pounds of D21, and X4 pounds of E11. These variables define the blend composition that we will optimize. The objective function is to minimize the cost of producing a 50-pound bag fertilizer. In this case, the total cost function is 6x1 plus 4.5x2 plus 5.5x3 plus 2x4. The takeaway for this is solving this optimization problem, we can determine the most cost-effective proportions of the 4 chemical components required to meet the Quain Growers fertilizer specifications. The chemical composition requirements for this fertilizer blend, it's what we are looking at here. The constraints ensure the blend meets both quality standards and production requirement. E11 minimum proportion. E11 must constitute at least 15% of the total blend. And the mathematical constraint here is C92 plus C30 combined proportion. The requirement together C92 plus plus C30 must make up at least 45% of the blend. D21 plus C92 combined limit. The requirement is that D21 plus C92 can together constitute more than 30% of the blend. And the total weight constraint requirement, the blend must weigh exactly 50 pounds. The takeaway here is these constraints ensure the blend is feasible, cost-effective, and meets the required specification for chemical composition and total weight. The optimal solution derived from the linear programming model. It demonstrates how the blend composition minimizes costs while adhering to all specified constraints. The optimal blend composition quantities of each chemical component is that 50 pound bag of the fertilizer meets the 7.5 pounds of C30, 15 pounds of C92, 0 pounds of D21, and 27.5 pounds of E11. The total cost per fertilizer, per 50 pounds of bulk fertilizer, in this case, is minimized. Effectiveness of the solution. This solution satisfies all the chemical composition requirements of E11 proportion equal or greater than 15%, C92 and C30 combined proportion equal or greater than 45%, D21 plus 92 combined proportion equal or less than 30%. The total weight is 50 pounds. The linear programming approach ensures the blend is both feasible and cost efficient. The key takeaway here is that this result highlights the power of linear programming in optimizing production costs while meeting the stringent quality requirements.
So in conclusion, the results of our team for the total cost is $3.35 for a 50-pound bag. As you see on the right is an Excel sheet table that explains the constraints of the left hand and the right side of the calculation slide. Based on the best quantity per bag, we see that there's 7.5 pounds is the best quantity for C30, 15 pounds is the best quantity for C92, 0 pounds is the best quantity for D21, and 27.5 pounds is the best quantity for E11. With those results, you can see it meets the constraints. E11 is at least 15% of the blend. C92 and C30 together is at least 45% of the blend. D21 and C92 together are less than 30% of the blend. And the package equals 50 pounds total. So our first recommendation that the group has researched using other chemicals for the best quality fertilizer. For an example, nitrogen-based fertilizer is utilized for healthy looking grass. Another recommendation that we researched is to increase the fertilizer cost in fall and in the spring. This result can increase the sales revenue, and this is the perfect time to fertilize according to New Jersey state government. As we reach the end of our presentation, these are the references that our team has used to complete our analysis. Thank you very much for listening in, and please reach out if you have any other questions. Thank you from Team 2.